Hey everyone, my name is Paul, and in this video, I'm replacing the cylinder head gasket on this 1976 Honda CB750. This video includes the procedure for taking the engine apart, replacing the head gasket, torquing the head bolts, adjusting the valve clearance, and adjusting the ignition timing. If you're seeing this video for the first time, I recommend you watch the whole thing so you don't miss anything. You can also use the chapter markers at the bottom of the video screen to jump to the part that you need. Alright, let's get started. I'll start by getting these nicely painted side covers out of the way. Each cover has one snap below and one above. This might look normal, but I don't recommend taking the panels off this way. They're extremely fragile and it's better to use a plastic pry bar on the snaps. Next, I'll be draining the oil. The side tank drain plug takes a 17mm socket. Pro tip, you can put a small funnel under the drain plug to direct the oil into the pan. Let's put the drain plug back in and get it tight so it won't leak. I like to tap the wrench with a hammer to loosen the drain plug. It's better than busting my knuckles when it breaks loose. This engine oil looks pretty good. Let's tighten the drain plug and move on. Next, I'm closing the fuel valves on the gas tank so I can pull the fuel hoses off. This bike has one on each side. Next, carefully remove the big bolt that holds the back of the gas tank. I'm moving the gas tank side to side a little while I pull it up and back. I have to be careful not to chip the paint by the fork. The pod filters come off next. They're just held on by hose clamps. These clamps can be unscrewed with a 1/4-inch nut driver or a Phillips screwdriver. The throttle cable is annoying to remove, plus I put the camera where you can't really see the cable. Half-assery is one way to approach this situation, I guess. Unhook the cable from the throttle cam on the carburetors, then unthread the adjuster until the cable comes off. Next, loosen the hose clamps closest to the carburetors. There are 4 of them. Rock the carburetors up and down to remove them from the motorcycle. The intake runners come off next. Or are they called manifolds? Rubber thingies? They're different, so keep them organized. Next, I'll be removing the ignition coils. Remove the spark plug wires by prying on the boots. Don't pull on the actual wire. The ignition coils have a ground cable going to one of the long valve cover bolts. Use a 5mm Allen key to loosen it. This bike has 4 cylinders and 2 coils. It's a waste spark system, meaning 2 cylinders fire at the same time, but only one of them needs it. The other spark is wasted. If you have a bad coil, you're likely to get a misfire on 2 cylinders instead of just 1. The cable going into the top of the valve cover is a mechanical tachometer driven by the camshaft. Put the bolt back in so you don't lose it. The exhaust manifold needs to come off the motorcycle now. Needle nose vice grips are perfect for grabbing those hard to remove exhaust manifold springs. Notice this engine has bolts holding the exhaust on. This is wrong. Bolts are hard to install and the risk of cross-threading the head is very high when bolting on the manifold. I'll be installing exhaust studs when I put this back together. Pull the exhaust off the bike and go get some new manifold gaskets because they're not reusable. This bike has a frame modification that allows you to remove the cylinder head while the engine is installed. If you don't have this, you'll either have to cut and weld your frame like this bike or remove the engine from the bike to work on the head. Taking the spark plugs out will make it easier to turn the engine over because you're not fighting compression. The spark plugs take an 18mm socket. I just use a regular socket, then grab the plugs with a magnet. This is a big project, so keeping the parts organized is key. I have a couple $50 tool carts from Harbor Freight, and I love them for stuff like this. It's time to remove the valve cover. The middle rectangle thing on the valve cover comes off next. If my terminology isn't good enough for you, please upload a better video. I'm serious, the world needs more good repair videos. The port coming off the center of the back of the valve cover is for positive crankcase ventilation, or PCV. The valve cover is held on by a bunch of long bolts. The Climber repair manual I'm using doesn't specify a sequence for loosening these bolts. You can start in the middle or the outside if that makes you feel better, but I don't think it matters on the valve cover. I loosen the bolts by hand and now I can zip them the rest of the way off with my impact driver. The 4 bolts in the corners are shorter than the other bolts. You can pry the valve cover up a little, but be careful not to scratch the sealing surfaces. I used silicone the last time I installed the valve cover gasket, so it didn't survive removal. I'll need a new gasket. Keep your parts organized so you don't get stuck putting together a big, greasy puzzle that isn't fun. I'll be removing the valve rockers next. The ignition cover is on the right side of the bike. The points and mechanical advance are located behind the cover. The points were upgraded to electronic ignition, but it still has mechanical timing advance behind there. I'll turn the crankshaft from here. Turn the engine clockwise until the two lines in the camshaft are flat with the cam cap and the keyway points up. This is top dead center on the number 1 cylinder. Cylinders number 3 and number 4 are on the right side of the bike. The number 3 and number 4 exhaust lobes are pointing down and away from the rockers, leaving some play. Use an 8mm socket to loosen the smaller bolts. They screw into the rod that holds the rockers. Remove the long cam tower bolt and slide out the rod. The number 3 and number 4 exhaust rockers can come out now. Rotate the crankshaft until the number 3 and number 4 intake cam lobes are pointing down and away from the intake rocker arms. Once you feel some play in the rockers, you can start to remove them. Take the two smaller bolts out and be careful not to drop the washers into the engine. The cam tower bolt holds the rocker rod in place too. Give the rod a push with a screwdriver and remove it. Now you can remove the number 3 and number 4 intake rockers. Now we're looking at the left side of the engine. Rotate the crankshaft until the number 1 and number 2 exhaust cam lobes are pointing down and away from the rockers. Make sure the rockers have up and down play before you remove the bolts. Take the bolts out and slide out the rod that holds the rocker arms. Now the number 1 and number 2 exhaust rockers can come out. Finally, rotate the crankshaft until the number 1 and number 2 intake cam lobes are pointing away from the rockers and the rocker arms are loose. Take out the bolts, take out the rod, take out the rocker arms. Now it's time to remove the camshaft from the engine. Use a 10mm socket to loosen all the cam bearing caps. Each cap has a long bolt on one side and a nut with a washer on the other side. If you're smart, you'll stuff a rag around the cam gear to prevent dropping parts down inside the engine, and you'll use a magnet to help you not drop stuff. Remove the two cam gear bolts next. You'll need to turn the crank to reach both of them. Push the cam gear off the camshaft toward the right side of the bike, pull off the chain, and carefully move the camshaft out. You'll need to rotate the gear to allow the cam lobes to pass through it. Do this part slowly and be very careful so you don't scratch the cam lobes. If you're smart, you can lay a towel down between the camshaft and cam towers to prevent scratches. Notice I have the orange thing holding the cam chain up. Make sure you keep all the parts organized so you can match the wear patterns if you're reusing your old camshaft. The cam towers are ready to come out now. Remove the 3 round rubber pucks from under the cam towers. They prevent oil from leaking out of the valve train. Both cam towers look very similar. If you're smart, you'll put a rag in the cam gear hole so you don't drop parts down into the crankcase. And here are the cam towers and plugs. I have a climber manual. It contains some good information, but some stuff is completely missing. For example, they don't tell you how to disassemble the valve train. Find a Honda factory service manual if you can, or just use this video. With the valve train all put away, we can move on to the head bolts. Actually, they're studs with nuts and washers. Follow the sequence on the screen to loosen the nuts by hand. The sequence starts in the middle and moves out. It's a good idea to loosen everything in 2 steps instead of all at once. This engine has 16 head studs. 6 smaller bolts also hold the cylinder head in place. They're not super tight, so a 1/4-inch drive ratchet is big enough to loosen them. If you're smart, you'll stuff a rag in the middle of the engine, then use an impact driver to remove all the head nuts. I'm following the sequence to remove them, but right now it doesn't actually matter because they're already loose. The magnet works great for grabbing the nuts and washers. My 3/8-inch drive 10mm socket was too fat to fit on the smaller head bolts, so I used a 1/4-inch drive socket instead with an adapter. Use a magnet to get the bolts out of the cylinder head. With all the nuts and bolts removed, the cylinder head is ready to come out. Pull the head straight up to remove it. You can pry a little bit if you need help breaking it loose, But don't you dare put a scratch between the block and head. I gently set the head on the studs. Get the timing chain out of the way and remove the head. This is a high-performance 3-layer metal head gasket. The rivets that hold the layers together were in the way, so they got drilled out during the previous installation. This engine has a lot of dowel pins between the cylinder head and block. The 2 pins on the front outer corners align the head and gasket. Oil flows past the head studs, and that's why it has 10 oil seals. The 8 oil seals and dowel pins between cylinders 1 and 2 and between cylinders 3 and 4 were an update from the older CB750 engine to help prevent oil leaking past the head gasket. The older cylinders have 2 oil seals total around the studs closest to the timing chain. Pry the oil seals up with a small flathead screwdriver or a pick. These oil seals fit together with the dowel pins. You can pull the pins out now or later when the studs are out. The 2 seals in the middle of the engine don't have dowel pins. Let's also remove the 2 outer dowel pins. Now it's time to remove the head studs. They are reusable, but I'm installing high-performance APE studs. Lock 2 nuts together onto the studs by turning them in opposite directions, then use the impact driver to remove the stud from the engine. Repeat the same technique to get all the studs out. Lock 2 nuts together, then use them to unscrew the stud. If you're installing new studs, I guess it's okay for you to just grab the old ones with vice grips, but I think this way is actually a bit faster if you're using an impact driver. Remember to keep your parts organized. Here we have 16 head studs and 6 small head bolts. The shorter 4 studs belong in the front of the engine. This cylinder head was installed recently, but the engine didn't run right and had low compression. The new head gasket was leaking, and I think the dowel pins had something to do with it. The head and block were milled and had 25 thousandths of an inch of material removed from them, but the dowel pins did not. Here you can see the indentation in the head where the dowel pin was pressing against it. Cylinder number 3 didn't fire at all because of low compression and some bad carburetor settings. I'm guessing these pins are the stock size. There are 8 shorter dowel pins that have oil seals around them. They measured 13.9 millimeters tall. I need them to be shorter. The 2 front outer pins align the head, and they are 17.9 millimeters tall. Also too tall now that material has been removed to make the sealing surfaces perfectly flat. I've read online from forums. I know, that's not a very good source. But theoretically, if you have a high-quality head gasket, you can just skip the 8 dowel pins and oil seals, and you won't have an oil leak problem. I will install only the 2 alignment dowel pins in the front corners of the engine. This is how Honda did it on the earlier engines. I'm using my precision angle grinder to take the 2 outer dowel pins down a couple millimeters. This doesn't have to be exactly right, as long as they're not too tall. It looks like there is still enough pin left to go through the head gasket and line up the cylinder head. This will work perfectly. Now it's time to install the head studs. You should remove the cylinders and pistons and chase the threads in the block. This is a fresh engine build, so I'm skipping that big, hard-to-do step. I'm applying assembly lube to the threads on the studs. This will help the torque wrench get an accurate reading. The longer threads go down into the engine. You can use Loctite instead of assembly lube here if you're paranoid about things coming loose. I cleaned the block with brake parts cleaner and scrubbed it a little with a Scotch-Brite pad. Don't use a wire brush, and be careful if you use a scraper because you can cut grooves into the block that will cause the new head gasket to leak. Insert all the head studs into their holes. If one side of the stud has longer threads, that side goes down. The shorter studs go in the front corners and middle of the engine. You should be able to turn them with your fingers. If not, you should chase the threads in the block with a tap to clean them up. Lock 2 nuts against each other by turning them opposite directions, then use the impact driver to run the studs down. Each stud must be torqued to 8 foot-pounds by hand. Turn the lower nut clockwise while holding the upper nut to unlock the nuts from each other without accidentally loosening the stud from the block. I'm using 2 nuts from the hardware store, not the nuts that came with the engine, because they get pretty beat up by using them like this. The thread pitch is M8 by 1.25. I'm using the Harbor Freight Quinn 3/8 inch drive digital torque wrench. If you're smart, you'll have a rag in the center of the engine so you don't lose your nuts down in there. You don't want to nut somewhere you'll regret. Continue until you've torqued every stud to exactly 8 foot-pounds. The digital torque wrench will give you a solid beep when you've reached the right torque. The goal is to be able to hold exactly 8 foot-pounds of force on the wrench and the stud won't turn anymore. Now it's time to install some exhaust studs. These are just M8 by 1.25 studs from the auto parts store. I'm installing the longer threads into the head. Exhaust studs make it easier to line up and install the header and will prevent you from cross-threading that head with shitty bolts that don't go in straight. Lock 2 nuts against each other and zip the studs down with the impact driver only after you're 100% sure you've threaded it in straight with a few turns with your fingers. I'm going extra tight with these studs because I get annoyed when studs unscrew with the nut. 10 foot-pounds is about the limit of how tight you can get these without damaging stuff. The digital torque wrench gives you a solid tone when it's tight enough. With the exhaust studs in place, we can move on to installing the head back on the engine. Now I'll flip the head over and give the sealing surface a final cleaning with a blue paper towel and some alcohol. I don't want any oil or dirt to cause the new head gasket to leak. Carefully wipe down the block to make sure there's nothing hanging out there. I'm installing 2 oil seals here and skipping the other 8. I hope this works. The head gasket looks blown up because the rivets are missing, but it's still new and I cleaned all the layers with alcohol. Push the head gasket down onto the head. I'm gently setting the head on the studs just forward of where it should be. Placing cardboard between the head and studs would prevent scratches. Before setting the head down, make sure these O-rings haven't moved and make sure the oil from the timing chain hasn't gotten on the head gasket. Feed the chain through the head, then gently lower the cylinder head over the studs. We can now torque the cylinder head nuts and bolts. Remember to put a rag in the middle so you don't lose the head nuts and washers down inside the engine somewhere. I'm installing 16 washers and nuts on the head studs now. Follow the sequence on the screen for tightening the nuts. Right now I'm just getting things finger tight. Make sure each nut has a washer under it. The cylinder head also has 6 smaller bolts. You can put your finger in the spark plug holes to help guide the bolts. The big long bolt goes up front. I'll be tightening the head bolts in 3 steps. The first step is hand tight, or 6 to 8 foot-pounds if you want to be a snob about it. The smaller bolts take a 10mm socket and are less hand tight than the nuts. Okay, now we're getting a bit more serious with a torque wrench. Tighten all 16 nuts to 14 foot-pounds following the sequence on the screen. I'm using a 1/4 inch drive 10mm socket with an adapter to my 3/8 inch drive digital torque wrench and tightening the smaller bolts to 9 foot-pounds. This engine has APE brand heavy-duty head studs. The recommended final torque is 22 foot-pounds. Apply pressure to the torque wrench until you get a solid beep and the nut does not turn anymore. Don't allow the display to go over 22 foot-pounds. If you want to be 100% sure everything is torqued perfectly, you can repeat the last step a few times until the torque wrench beeps at 22 foot-pounds and you don't get any movement out of the nut. Switch over to the 10mm socket and tighten all the smaller bolts to 9 foot-pounds. Yes, it's the same torque as before. Before the cam towers go back in, there are 2 small oil jets that must be installed. These are similar to jets in a carburetor and they control how much oil goes up to the camshaft. If you forget the oil jets, you'll have too much oil going up top and you won't have enough oil pressure in your main and connecting rod bearings. This engine has 2 oil jets, 1 for each cam tower. Each jet has an O-ring. You can add some silicone, but be very careful not to plug the jets. On the outer edges of the engine, there are some round indents. They just get some O-rings and sealer. If you forget these O-rings, your camshaft won't have enough oil pressure. Each cam tower has 3 round pucks under it. These just prevent oil from leaking out of the camshaft area. Now we're ready to install the cam towers. The oil jet is important because oil is metered through there, goes up here, lubes your camshaft, and then it wants to come back out here, but this is sealed. So it's important to seal that because if it's not, you'll leak oil past here and you won't get enough oil pressure to the camshaft. Likewise, if you forget to install the jet, you'll get too much oil flow up here and you won't have enough oil pressure for the bottom end of the engine. So the main bearings, connecting rod bearings, that kind of stuff could get excessive wear. Two long bolts hold each cam tower down. I'll be taking these bolts back out to install the rocker arms, so no need to torque them yet. I'll just go hand tight. The camshaft is ready to go back in now. Assembly lube is thicker and more sticky than motor oil, and it will lube the parts before oil pressure builds up in the engine. Start installing the camshaft from the left side of the motorcycle. You'll need to feed the camshaft under the timing chain and through the cam gear. The gear has cutouts for the cam lobes. Rotate the gear to allow the camshaft through. Go slow and be careful not to scratch the cam lobes and bearing surfaces. With the camshaft in place, the next step is to install the timing chain correctly. I want to find top dead center on cylinder number 1. Turn the engine over slowly by hand using the nut under the ignition cover on the right side of the engine. Hold the timing chain up so it doesn't get caught on the camshaft. Notice my stick is getting pushed out of the engine as the number 1 piston reaches the top of the cylinder. You should see the numbers 1 and 4 and the letters T for top dead center and F for fire. Line up the T with the timing mark on the engine case. Now turn the camshaft so the keyway points up and the two lines are flat with the cam tower. Pull the chain tight at the front of the engine and line up the bolt holes in the gear with the holes in the camshaft. Install one bolt to hold the cam gear. Loosen the holding bolt on the cam chain tensioner so the spring pushes on the cam chain guide. Install the cam chain tensioner. One bolt is enough for now. Now turn the engine over 2 complete revolutions until you get back to the top dead center mark. The camshaft lines should be flat with the cam tower. It looks like my cam is a little bit too far clockwise. I'm removing the cam chain tensioner, then the cam gear bolt. Slide the cam gear away from its mounting point to get some slack on the chain. I want the cam to move back 1 tooth, so I'm moving the chain forward on the gear by 1 link. Now let's put the cam gear back on. Reinstall just 1 bolt for now, then the cam chain tensioner. Turn the engine over 2 complete revolutions and stop at the T. Watch the camshaft as you get close to top dead center. The keyway should point up and the lines should be flat with the cam tower. It's very close now. Before, it was obviously off by 1 tooth, but now my camshaft seems like it's just 1 or 2 degrees counterclockwise of where it should be. This is because material was removed from the cylinders and head, making the chain length shorter on the front of the engine. Getting an adjustable cam gear or ovalizing the cam bolt holes could get this aligned better. I'm actually not going to worry about it. With the timing chain installed correctly, I can now torque the cam gear bolts. Rotate the engine so you can reach the second bolt and thread it in. You can put a 1/4-inch drive extension through a hole in the cam gear to hold it, or you can hold the crank bolt and the timing chain will prevent the cam gear from turning. I really don't want these bolts coming loose, so adding Loctite and going extra tight at 11 foot-pounds is a good idea. The digital torque wrench will make a solid tone when the correct torque is reached. Check each bolt twice to be safe. Now let's set the cam chain tension. Let's take the tensioner out and clean the sealing surfaces. Scrape off the old silicone and clean it with alcohol. I put a thin coat of silicone sealer on both the engine and the tensioner assembly. Make sure the bolt on the tensioner is loose so the spring can move. And now we can install 3 bolts that hold the cam chain tensioner. These bolts get torqued to 9 foot-pounds. Cam chain tension should be locked in when the engine is at 15 degrees after top dead center. It isn't marked, but it's just past the pin. Double check to make sure this bolt is loose. At 15 degrees before top dead center, all the tension's in the front of the timing chain and all the slack is at the back, which is the perfect time for the chain tensioner to take up the slack. Now, that spring is not strong enough to use while you're riding the bike, so we're gonna lock it in. Tighten the bolt all the way down until it doesn't turn, then tighten the nut to lock in the bolt. Now the timing chain tension is set. The camshaft bearing caps will go in next. Generously apply assembly lube to the camshaft bearings and lobes. This is the only lubrication it will get for the first 30 seconds before you get oil pressure. Each bearing cap has letters stamped into it. Match the letters on the caps with the letters on the cam towers. Don't mix these up because a mismatched bearing surface can destroy your camshaft and cam towers. Each bearing cap gets a long bolt on one side and a nut with a washer on the other side. With all the bolts installed, it's time to torque them. I'll start by snugging everything down hand tight. With the torque wrench, I'm tightening all the bolts to 9 foot-pounds. Hold pressure on the wrench as evenly as possible and don't exceed the torque spec while tightening. You've reached the correct torque when you get a solid tone and the bolt won't turn. Now it's time to install the valve rockers. Make sure the engine is at top dead center for cylinders 1 and 4. The keyway on the camshaft will point up and the number 3 and number 4 exhaust cam lobes will be pointing down. Set the number 4 exhaust rocker down and insert the rod with the chamfered end of the threaded holes pointing up and the flat slot on the end facing the outside of the engine. The long cam tower bolt is in the way, so we need to remove it. Install the number 3 exhaust rocker, then slide the rod the rest of the way in. The bolt helps hold the rod in place. 2 smaller bolts with washers lock the rod in place. Just go hand tight for now. Turn the engine clockwise until the number 3 and number 4 intake cam lobes are pointing down. Install the number 4 intake rocker and slide the rod in. Get the long bolt out of the way and install the number 3 intake rocker. Drop the long bolt back in. Use a flathead screwdriver to turn the rod if you need to line up the threads for the smaller bolts. Now we're looking at the left side of the engine. Turn the engine clockwise until the number 1 and number 2 exhaust cam lobes are pointing down. Install the number 1 exhaust rocker, get the bolt out of the way, install the number 2 exhaust rocker. Reinstall all 3 bolts. I'll torque these later. Turn the engine clockwise until the number 1 and number 2 intake cam lobes are pointing down. Install both intake rockers and don't forget about the bolts. Use a 10mm socket to torque the long cam tower bolts to 9 foot-pounds. The 8 smaller bolts only go to 4.5 foot-pounds. My torque wrench doesn't go that low, so I'm doing this part by hand. These bolts can break easily, so be careful with them. Now it's time to adjust the valves. Turn the engine over by hand until you reach top dead center for cylinders 1 and 4. Make sure the keyway on the camshaft points up and the lines are flat with the cam bearings. There should be some play between the rocker and number 4 exhaust valve. I'm setting the exhaust valve clearance to 7 thousandths of an inch. You'll need the 7 thousandths feeler gauge and the 8 thousandths. The 7 slides in easily. The 8 can go in easily too. This rocker is too loose. Loosen the nut with a 10mm wrench, then place the 7 thousandths of an inch feeler gauge in the gap and turn the adjuster clockwise with a flathead screwdriver until it's barely finger tight and it's hard to slide the feeler forward and back. Hold the screwdriver and tighten the nut. Let's check again. The 7 slides easily and the 8 goes in too. The rocker is too loose. Loosen the nut, turn the adjuster clockwise just a hair, tighten the nut. Now the 7 has some resistance, but I can still force the 8 in there. The rocker is too loose. Let's tighten it just a little bit more. I can still push and pull the 7 thousandths of an inch feeler gauge, but the 8 won't go in there. Now it's good. Let's check the number 3 exhaust valve. The 7 goes in with some drag, but I'm also able to force the 8 in there. Let's tighten it just a little. Now the 7 won't go in. It's too tight. Loosen the rocker just a little bit. It's hard to push the 7 thousandths of an inch feeler gauge and the 8 won't go in. This one is good. We're still looking at the right side of the engine. Turn the crank until the number 3 and number 4 intake cam lobes are pointing down and away from the rockers. You should have some play in both. I'm adjusting the intake valve clearance to 5 thousandths of an inch. The 5 and 6 both fit loosely. I need to tighten this rocker. The 5/1000ths of an inch feeler gauge takes a lot of effort to push through the gap, and the 6 doesn't fit at all. This one is good. Moving on to cylinder number 3, intake valve. Let's tighten the adjuster against the 5/1000ths feeler gauge. I can push it and I can pull it, and the 6 won't go in. This one is good. Now we're looking at the left side of the engine. Turn the crank until the exhaust cam lobes are pointing down and away from the rockers. The 7 8/1000ths feeler gauges fit easily above the number 1 exhaust valve. Loosen the nut, tighten the adjuster slightly, and lock it in with the nut. Now the 7/1000ths of an inch feeler gauge is hard to move and the 8 won't go in. Good. Both the 7 and 8 feeler gauges fit loosely under the number 2 exhaust valve rocker. Tighten the adjuster and try again. It's hard to move the 7 and 8 won't go in. Cool. Turn the engine clockwise until the number 1 and 2 intake cam lobes are pointing down and away from the rockers. The 5/1000ths of an inch feeler gauge fits above the number 1 intake valve, and with a bit of force I can get the 6 in there too. Tighten the adjuster to about 1 Newton meter with the feeler gauge under it, then lock it in. The 5/1000ths feeler gauge is hard to push and 6 won't go in. And finally, I can push the 5 in between the number 2 intake rocker and valve, and 6 won't go in. This one is adjusted correctly. Okay, we're almost done here. Let's put the valve cover back on. Clean the sealing surface with alcohol and install the gasket. Silicone sealer is not needed here. Now the valve cover is ready to go back on. The valve cover has 10 long bolts and 4 short bolts. The short bolts go in on the left and right sides of the engine. Start the bolts by hand, then you can zip them down with a drill if you want. I'm tightening the bolts in the middle first and moving my way out. Apply a little silicone sealer and install the rubber seal on the PCV cover. PCV stands for positive crankcase ventilation. The short bolt goes in front and 2 longer bolts hold the back of the PCV cover. Torque all the valve cover bolts to 7 foot-pounds. I'm starting in the middle and moving my way to the edges of the engine. You've reached the right torque when the digital torque wrench makes a solid tone. The tachometer cable has a slotted piece that must line up with the gear in the valve cover. If it doesn't go all the way in, turn the cable with a flathead screwdriver and try again. The cable is held in by 1 small bolt. The spark plugs will go back in next. Start by setting the spark plug gap to 26/1000ths of an inch or 6 millimeters. Gently set the spark plugs in place and use an 18mm socket to tighten them. They need to be tight enough to compress the washer and create a seal, or about 13 foot-pounds if you want to use a torque wrench. Now it's time to install the exhaust. The exhaust seals get crushed, so they are not reusable. The new copper seals don't need sealant, but I'm adding just a little bit so they don't fall out while I'm installing the pipe. The sealant will probably burn off after a while. The collars will need to rotate a bit to get past the frame. Make sure the small spring holes are all facing up and add some washers. I'm using locking exhaust nuts. The end of the nuts are oval shaped so they don't get loose. I'm tightening all the nuts to 12 foot-pounds. Torque every nut, then go back through and torque them all a second time. Needle nose vice grips make the spring installation very easy. Now the frame brace is ready to go back in. This is a modification that allows you to work on the engine while it's still in the bike. The coils will go back in next. This bike only has 1 bolt holding the coils in place. It's a little ghetto, but it works fine. The coils are also grounded to the valve cover. The blue and yellow wires get their ground from the ignition module, and the black with white stripe is power. The left coil is for cylinders 1 and 4. The left cylinder is number 1. They fire at the same time, so if you mix these up, it doesn't matter. The right coil is for cylinders 2 and 3. They fire at the same time, so if you mix them up, it doesn't matter. We're almost done. Let's put the carburetors back in. The rubber intake boots are a tight fit, so a little dielectric grease helps them slide on. Rotate the intake runners so the holes are all flat with each other. The intake runners are all labeled. Here we have 1, 2, 3, and 4. If you turn these over, number 4 is actually the same part as number 1. Now we can install the carburetors. Rock the whole assembly up and down as you push them into the rubber boots. Rotate the hose clamps to make them easy to reach, and tighten all of them with a 7mm socket. Installing the throttle cable is very annoying. I stuck a screwdriver in here to hold the throttle, and I'm getting the spring out of the way. Insert the end of the throttle cable into the appropriate hole. Using small needle nose pliers and a small flathead screwdriver makes this a bit easier. With the end of the cable hooked up, thread the adjuster bolt into the bracket. Adjust the cable so there is a little bit of play. Make sure the throttle cam hits the idle speed adjuster bolt when you let go. This looks good. Tighten both nuts to lock in the throttle cable adjustment. Remember to reinstall this other spring here. I have a set of small pliers that work great for stuff like this. Now the pod filters go back in. Rotate your hose clamps so you can reach them with a nut driver from the side of the motorcycle so you can work on them with the gas tank on. And finally, don't forget about the crankcase breather hose. Now it's time to install the gas tank, but first I have some better fuel valves. Let's get these old ones out of here. Silicone sealer is resistant to gas if you let it dry for 24 hours first. These fancy fuel valves are made by Pingel, and this gas tank is from a 1977 Yamaha XS750. Start the tank on the front rubber bushings and gently wiggle it into place. This bike has one big bolt holding the tank at the back. Now just connect the fuel hoses. Just add some fluids and this motorcycle will be ready to ride. Pour 3.7 quarts of oil into the side tank. It might need a little bit more if you change the filter. Use the dipstick to determine the exact oil level. Using oil with ZDDP additive is a good idea. Basically, it creates a thin layer of zinc on the metal parts and reduces engine wear. Using oil that is high in zinc is recommended on older engines. If you replaced your cylinders and you want to make sure your new piston rings seat properly, use break-in oil in your engine. The Spectro oil I used has ZDDP and is a good oil to use after the rings are already seated. Use 91 or higher octane gas, preferably without ethanol if you can find it. Let's adjust the ignition timing. Connect the timing light to the battery terminals. The inductive pickup can connect to the number 1 or number 4 spark plug wire. Open the fuel valves, key on, kill switch off.
Okay, now it's on the F. It's not advanced 3 degrees. Go ahead and do a rev test. Go forward just a hair. Okay, try that.
When you have the correct timing, tighten the 3 bolts holding the ignition module. Now I'm adding a little custom-built bling here. The ignition cover is held on by 2 bolts. I saved the side covers for last. They're very fragile, so you don't want to touch them any more than you have to. I recommend adding dielectric grease to the rubber grommets so they don't get stuck.